we have the Platform Industry 4.0, which is the organization which is taking care of supporting the industry with everything necessary. And these are the visions for 2030. So one is autonomy, so self-determination and free scope for action guarantee competitiveness in digital business models. So we need actually access to technology developments. Also smaller companies especially need this. We need a good security system, because more digital exchange is of course more dangerous. And we need digital infrastructure. The interoperability has to be given. So for especially small companies, it's important that there is a standards and integration, and some regulatory framework so that they can easily integrate all the technologies into their companies. And that's what all the members told. Sustainability is a big point. The digitalization of industry actually helps in that field, but of course industry and government have to want this and to follow this. The technology can help, for example, knowing exactly what kind of materials are in your product through having this digital twin. But then, of course, you have to actually force your suppliers also to offer sustainable products. Because all these things might be very abstract, I wanted to give some examples. So the Platform Industry 4.0, which in Germany actually works on the strategy, but also SME, small and medium-sized company mobilization, and on international cooperation, because one country cannot do this alone. If you sell your machines and in the other country there's a completely different standard, then it doesn't function anymore. So we have to collaborate international. So this is Industry 4.0 platform. The head are two German ministries, Research Ministry and the Economic Ministry. And below are, I don't want to go into detail, but below are industry associations, but also scientific laboratories and so forth. So there is a standardization council. This is a very big thing to standardize the whole process. And in Germany, we have a lab network, Industry 4.0. And here also you find the Fraunhofer institutes and universities that actually run test labs where also companies can come and really learn about new developments and also pre-develop some things. So they altogether have several use cases, and on the homepage of the German platform Industry 4.0 you find 300 use cases from Germany, 150 from France and 150 from Japan. And there is a very close collaboration in Japan with the Robot Revolution Initiative. Just to give some brief explanations of some practical examples that are also given in these use cases. So one is Bosch. Bosch is of course quite a big player. They have big factories like you see here in this picture. This is a factory in Bleichach. It's a little bit south, I think, from Stuttgart. And I just gave this example because here actually processes and workflows in production and logistics actually were simplified through greater availability of relevant information. So it's not that they threw away the whole factory and bought a new one. They just gathered more information, and this already helps quite a lot to improve the whole process. And of course, the people, the employees, have to be involved in that. This is a nice example for a so-called smart product. We saw that on the bottom, the smart product also has IT capabilities, and here it's actually very simple. It's a small company from Germany, Wolfkran. They have 800 employees, and they make this kind of construction cranes, which are used all over the world. And what they did is actually they just replaced GSM modems with the cellular industrial router. And through this, actually, the crane, if the crane through its sensors detects some irregularity or some problem, this crane automatically sends a SMS to the headquarters, and there some people can take care and log into the crane and do some maintenance. And even this opens actually what is called predictive maintenance. So some small irregularities already indicate or predict some future problem which should be maintained. One use case from Japan is also very interesting. So here, this is a die for making injection molded plastic parts. And here the company just equipped this with additional sensors like temperature, pressure, and vibrations. And these embedded sensors actually measure data that were not known before. So by having this additional data, they get a much better impression or knowledge about the process and can further optimize this. So again, here, you don't need a new machine, you can equip it, and then it works well. Another example from the middle part, the so-called smart factory, is actually, so smart factory, the ideal image is that every product you produce can be different. So you have a lot of one, or you have, like here, this is a furniture maker, so day-to-day commissioning. So every day he produces different furnitures, and here actually they developed an in-house cyber physical system, and this actually ensures that the workstations, so for example here where somebody is working, or here, that the workstation actually have some data exchange between the product or the workpiece, this cyber physical system, what they developed, and the machine. So like that, actually, the employees can see on such a screen, or here on the screen, they can see all informations about the product to be manufactured, and also about the other workstations before and behind them. And a very German example is beer production. And also here, I want to show this because it's very simple. So normally on this brewing vessel, you have this, on top you have this meters for temperature and things. So people go and they make some note. What they did here, this is the research brewery of Technical University of Munich. So what they did here is just they put sensors for example, here this meshing for this, the speed which is using, and temperature and pressure, and they put this into all processes, and with that they could gather informations they otherwise don't have.